Alright, so in this video we're going to do example number 5. I apologize that it is filled out already. I just did the whole problem and then had a technical glitch on the video. And so I'm going to read it through with you here. The directions are to evaluate this definite integral. Just like on the problems before, I want us to think about just how to do it first, and then think about the claim that is being made and use Desmos to visualize that argument. All right? So I know that I have to come up with an antiderivative for the function right here. And before I can do that, I need to see that this function is one function of x, 4 minus x, times another function of x, square root of x. I cannot, just like I can't differentiate, I can't integrate, i.e. anti-differentiate, across multiplication, across factors. So I'm just going to go ahead and clean up my algebra here. I'm going to use my distributive property. 4 times square root of x is 4 square root of x minus x times square root of x. Excuse me. And then I know now I've got terms. I've got one object minus another objects. Doing this integral is nice. I can compartmentalize my thinking. I'm going to want to do power rule in reverse, right? Adding 1 to that exponent, dividing by the new exponent. So let's go ahead and write, in preparation for that, write the square root of x as x to the 1/2 power, right? Just that's all I did from there to there. And now using these laws of exponents, again, just cleaning up this algebra, we've got a constant times a function of x, great, I'm happy with this, minus x times x to the 1/2 power. I'm going to want to, base is the same, add those exponents. 1 plus 1/2 is 2/2 plus 1/2, which is 3/2. So this is just algebra from here to here. Now I'm going to do my calculus. So we're going to come up with an antiderivative for this function. No plus c needed here. And then we're going to evaluate it at the endpoints. All right, so the integral of this constant 4 times the function of x is that constant 4 times power rule in reverse. We're adding 1 to the exponent. 1 is 2/2. So that's our new exponent. And then we're doing what? Division by the new exponent. All right. Same deal here. X to the 3/2. Okay, power rule in reverse. You're adding 1 to that exponent to get 5/2 and dividing by the new exponent. Now, before I go ahead and plug in these endpoints using Fundamental Theorem of Calculus Part 2, let's just clean up our arithmetic in here so that it makes it easier to evaluate when we plug in, right? So division by 3/2 is multiplication by 2/3. Division by 5/2 is multiplication by 2/5. Multiplying my fraction straight across here, 4 times 2 is 8, 1 times 3 is 3. And x to the 3/2 power, you can choose to leave it like that, but I know I'm going to plug in a 4. So I'm going to go ahead and write x to the 3/2 power as the square root of x cubed, right? Just recall x to the m over n is the nth root of x to the m, which is the nth root of x, all raised to the m. You have a choice there. And let's get a little color. The denominator is the root that you were taking. I'm writing it like this because I'm plugging in a 4, and I know 4 is a perfect square. All right, and also x to the 5/2 power is the square root of x to the 5th. So just did a little bit of algebra arithmetic cleaning up right there. Now, fundamental theorem of calculus part 2. We're going to go ahead and plug the 4 in where we see an x. That's what we have right here. And then minus plugging in a 0 where you see the x. All right. Square root of 4 is 2. Cubed is 8. 8 times 8/3, multiplying fractions straight across. 8 times 8 is 64, so you have 64/3. And then square root of 4 here is 2. 2 to the 5th is 32. 32 times a minus 2/5 is minus 64/5. And then this one's fun. We got a 0 minus 0, which is 0. Getting a common denominator here to subtract these fractions, we end up with 320/15 minus 192/15, which is 128/15, and we're done. All right, so let's just review those steps and then think about the argument that we've made. I can't integrate across multiplication. That's all right. I'm going to go ahead and use my distributive property, clean up the arithmetic so that now doing power rule in reverse is easier for me. Power rule in reverse is always adding 1 to the exponent and dividing by the new exponent. Here, we got our antiderivative, and now we're just cleaning it up, not doing any calculus, but just cleaning it up for the purpose of making it easier to plug in these endpoints. Now, from here to here, we're doing calculus. We're doing fundamental theorem of calculus part 2. I'm plugging my 4 in first, minus plugging in my 0 next, and then it's just arithmetic, and we have our answer. Sorry, I have the sniffles here. What is it that we have found? All right, so we've been asked to find the area under this purple curve, 4 minus x times the square root of x, as x goes from 0 to, what's b? 0 to 4. So we're asked to find this blue area right there that's under the purple curve. That's a hard question. That's a limit of a Riemann sum. Instead, because we could come up with the antiderivative function, and that is the one that we came up with, right? 8/3 x to the 3/2 power, right? X to the 3/2 power minus 2/5 x to the 5/2 power. That's what we came up with. Square root of x to the 5th is x to the 5/2 power. All right. And this is just so amazing that evaluating that antiderivative at the endpoints, in other words, f of b is 4 now, f of 4 minus f of 0, that height, that length right there is the same number as the area under this curve. And that number, 8.53 continuing, that number you can see here is the 128/15. Really, really elegant. All right, and just looking at a nice picture that I drew from a previous semester. Sometimes looking at both the graphs on Desmos can be a little overwhelming. So here is our purple function, 4 minus x times the square root of x. We're looking to find the area under that function as x goes from 0 to 4. Instead, you came up with the green function, that antiderivative function, and evaluated it at the endpoints. Plugging in a 4 first to get 128/15, plugging in the 0 next to get 0. The difference there is that 128/15, that length is the exact same number as this area. Really, really remarkable stuff.